With number 40, we get to take a look at two-dimensional interference, meaning we have the interference of waves from two sources in 2 dimensions. And this picture here shows us a representation of what we mean. Each source, source 1 and source 2, emits circular wave fronts. And if we take a look at, say, point Q, the distance that the wave travels from source 2 to point Q differs from the distance that the wave travels from source 1 to point Q. And so if that path length differs by a full cycle, we're going to get constructive interference. And if it differs by a half cycle, we're going to get destructive interference. Now it's worth taking a look at the actual wavefront pictures that are here. In the case of point Q, we can see that we have a crest from wave 2 intersecting with a trough from wave 1. Here we go, crest, 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 and here's the trough in between 2 crests coming from source 1, whereas we have this lying on a crest from source 2. So we can predict from the diagram, or see from the diagram directly, that we have crest aligned with trough, and we're going to get destructive interference at point Q. Taking a look at point P, you can see we have crests from both waves, so we expect this to be constructive interference. And point R, we have a trough from source 2, and we also have a trough from source 1. Now something to note is that trough to trough, that's still an alignment of the 2 waves from the sources. So that's actually a point of constructive interference because we have 2 troughs aligned with one another. The waves are still aligned relative to one another, and so that is constructive interference when they line up. It's still going to have maximum displacement, even if it's maximum downward displacement. But at point Q, where we have trough aligned with crest, this is a situation where we have an up displacement matched with a down displacement, and that's the situation in which things cancel and we get destructive interference. That was just a little bit of introduction. Let's go ahead and do the problem as it's described. It says the figure shows circular wavefronts emitted by 2 sources. Make a table with rows labeled P, Q, and R, and columns labeled R1, R2, delta R, for path length difference, and then we have to choose whether it's constructive or destructive interference. So let's take a look at how this works. So at point P, from source 1, we go 1 lambda, 2 lambda, 3 lambda. So R1 is 3 wavelengths lambda, and R2 is 1 lambda, 2 lambda, 3 lambda, 4 lambda. 4 lambda. The difference between the path length difference here, delta R, is going to be 4 lambda minus 3 lambda. In other words, point P is a full cycle closer to source 1 than it is to source 2. This is just going to be a path length difference of lambda. Since this is a full cycle path length difference, this is constructive interference. At point Q, we have 1 lambda, 2 lambda. That is the path length from source 2 to the point of interest Q. From source 1, we have 1, 2, 3.5 lambda. So 3.5 lambda minus 2.5 lambda is 1.5 wavelengths. And since this is not an integer number of wavelengths, but a half integer instead, this is destructive interference, crest to trough. Now for point R, we have, coming from source 1, we have 1 lambda, 2 lambda, 2.5 lambda. Coming from source 2, we have 1 lambda, 2 lambda, 3.5 lambda. The difference, the path length difference, is going to be 3.5 minus 2.5, which is just 1 lambda. And that's an integer number of wavelengths, so that's going to be a constructive interference condition.